Hi, good afternoon, all. This is Vishal Singhal from Cellstride, your host for today. So we have our intern from Cellstride AI Lab, as well as a computer vision researcher, Mr. Manjeet Singh from Perth, Australia, who's taking us through number plate detection. So transferring the controls to Manjeet. Are you ready?
Yes, yes. Hi guys, this is Manjeet. Today we are going. Is
Now
it
you may
visible?
start.
Yeah,
Yeah.
my screen is. Yeah. Hi guys, this is Manjeet. Today we are going to learn how to train YOLO for detecting license plate recognition. So this is broadly what we are going to cover: a brief intro to the YOLO architect, then step by step training how to train YOLO for single class classification, as we are just concentrating on a license plate, which is a single class, and how to annotate images for the YOLO. So YOLO stands for you only look once. It is a real-time object recognition system that can recognize multiple objects in a single frame. YOLO recognizes objects more precisely and faster than other recognition systems. It can predict up to 9,000 classes and even unseen classes. It can be easily trained and deployed in a production system. The object detection algorithms using deep learning can be classified into two groups. Classification-based algorithms are mainly two stages in the classification-based algorithm. In the first stage, it will select a bunch of region of interest in the image where the chances of objects are high. In the second stage, it will apply a convolutional neural network to these regions to detect the presence of an object. One example of this type of algorithm is RCNN. A second one is regression-based algorithm. In this algorithm, there is no selection of region of interest in the image. Instead of that, it will predict the classes and bounding boxes for the entire image at once. This make detection faster than classification algorithm. One of the famous regression model that we are going algorithm that we are going to cover is YOLO. The YOLO detector is very fast, so it can be used in self-driving cars and other applications where real-time object detection is required. Let's talk about the brief architect about the YOLO. YOLO is based on a single convolutional neural network. The CNN divides an image into region, and then it predicts the boundary boxes and probability for each region. It is simultaneously predict the multiple bounding boxes and probability of those classes. YOLO architect consists of backbone, neck, and dense prediction. The purpose of backbone is a feature extraction. It aims to reduce the number of features in a data set by creating a new features from the existing one and then discarding the original features. These new reduced set of features should then be able to summarize most of the information contained in the original set of features. The purpose of neck block is to add extra layer between the backbone and the head and the dense prediction. This is to enrich the information that feed into the head. Neighboring features, map coming from the bottom up stream and top down streams, are added together element-wise or concatenated before feeding into the head. Head, or which is dense prediction, is a part used to locate bounding boxes with confidence score for a class. Secondly, it classifies what inside in each block. The YOLO detector can predict the classes of object, its bounding boxes, and the probability of the class of the object in the bounding box. Each bounding box is having the following parameter. This is the probability. Bx and By is the center of the image, which is here. BH height, BW, it's a relative absolute relative height and width with the image, and C is the class. And each bounding boxes have an associated probability value. As the YOLO is not looking for interesting ROI, region of interest, instead of that, it is splitting the images into several cells, typically using a 19 by 19 grid. Each cell is responsible for predicting 5 bounding boxes. If it does that, it will finally end up with 1805, 1805 bounding boxes for one image. Most of the bounding boxes in the cell may not have an object. The filtration of these bonding boxes is done based on the probability of the object class. Then we use non-max suppression. A process will eliminate the unwanted bonding boxes, and only the highest probability bonding box will remain. YOLO comes with the bag of freebies and bag of special thing. So YOLO is a combination of you can say combination of different softwares modules, and these two modules we are going to discuss in brief. That is, these are the categories of method that are used to improve the object detector accuracy. They analyze different method in both categories to achieve fast operating speed neural network with good accuracy. These categories are bag of freebies and bag of specials. Bag of freebies method can make the object detector receive better accuracy without increasing the inference cost. These methods only change the training strategy or only increase the training cost. An example of a bag of freebie is data augmentation, which increase the generalization ability of the model. To do this, do photometric distortion like changing the brightness, saturation, contrast, and noise, or we can do geometric distortion of an image like rotating it, cropping it. These techniques are a clear example of a bag of freebies, and they help the detector accuracy. Bag of special plugins, modules, and post-processing methods that only increase the inference cost by a small amount but can significantly improve the accuracy of the object detectors. As stated in the paper, these kind of modules usually involve introducing attention mechanism, enlarging receptive fields of the model, and strengthening features, integrating capabilities, among others. YOLO 4 use lot of mesh activation function in the backbone. So let's see how we can use YOLO to detect license plate detection. This is the output that we are looking for. If we feed an image, and this is the output that we're looking for. So first step is download Darknet from this link, and we are going to make build this repository. And to test this, we need YOLO 4 weights, which is they already trained it, and this is the test. Let's see how we can do that. So I already downloaded this repository, which is in the zip format. And after extraction, we come up with the Darknet master folder. In this, we have to edit make file. According to your system configuration, if you have a GPU, you can make it one, like the example that I'm showing in. I got GPU. Then we need a, if we have a GPU, then we all definitely have a CUDA. I'm just making it one. because it's according to the system configuration. Open CV, and we also need a library. So I'm keeping this. These are the minimum parameter you need to change. If you don't have a GPU, just make it 0. This is compatible with both GPU and CPU. Let's save it. I already created an environment for in the Conda for YOLO. It's all just need, let's see, the few library it's required is, so NumPy, OpenC. For Darknet, you don't need lot of installation. OpenCV will work, and NumPy and pip. As we made the changes here in the make file, to build Darknet, we just need to run a make command, and it's already, my system already contain a C, so it's using a C to compile it. It will take within a minute. It will compile, and we have a library and built ready. So it's done. Yeah. In a in this Darknet, or which is YOLO, YOLO 4, you have to download YOLO 4 weights. It does not come with the repository. In a special link, you have to download this weight, and we can test it. To test, we can use if our installation is right or not. This is the configuration file for the YOLO 4. Then YOLO 4 weights, data, image that we are going to pass. Yeah. So it's done. And here in the prediction, where is the, wait a minute, I'm just looking for where the result is gone. Yeah. Oh, okay. So weights actually. Yeah. It's because of the resolution, it's not able to show it because I'm using a different system to test this. So I don't know, something went wrong here, but definitely we are able to cannot load. Uh, sorry guys. Yeah. So first was the configuration file. I wrote it wrong. Then the weights. Now the image thing. So yeah, this is how you can download and build Darknet on your own system. Okay, and to train with this, we can just okay, the Darknet is installed properly. This is just the first step. The second step is to train it for detecting license plate. That's what we have to do. Let's see what we have to do. For trading, we need to download another weights. They already provided, the Darknet already providing it. We start our training with YOLO 4 convert 137 instead of YOLO 4 weights. We have to change the YOLO 4 custom CFG according to our requirement, as we are using only a single class. So we need to mention on how many classes we are going to use, size of the network, width and height, filter, need to change filter accordingly. Let's see how to do that. So you can find this CFG file here, YOLO 4 custom CFG file. Change this in a training batch 64. Batch 64 means and at a one time how many images we want to process, and further dividing this batch in by 16, subdividing it by uh, this batch in subdividing by 16. So 16 into 16, 32, or 4 sub batches. Width of an image in a network, width and height, channel, RGB, we are taking a 4 RGB, and these are saturation, exposure, hue. For data augmentation, we are not going to change it. So next batch, because we are using one class, so what they suggest is take 2000 per class. So as we have a one class, we are only taking 1 into 2000. Other, if we have a three classes, it will be 6000. Then we need to change number of lines here, steps, which is 80% and 90% of the max batch. 80% and 1800 here. These are the basic changes we need to make in here. One more change we need to make. We need to mention the filters. Right now, the default configuration comes with the 255, but here we need to change the filters to filter to classes. We are taking only one class plus 5 into 3, which come up to 18. 1 plus 5, 6 into 3, 18. we have to look for YOLO here, and before that, the convolutional here, we need to make it 18. 3 times YOLO will come. There is and we have to make 3 changes in there. Again, 18. Here. To start training, these are the minimum changes we need to do. "18" here, 18 here, filter 3 times, and 18 here. And the changes we did: batches, subdivision, width will remain same, height will remain same, but you can change according to your requirement what you are going to feed in it. And we have only one class, so the batch will be max batch will be 2000 steps, 80% and 90%. This is one of the configuration that we changed. There are more we need to change for it.
One question, Manjeet.
Yes, please. Yeah.
What is the logic behind the filter formula that was given in the slides? Is it given by YOLO documentation or something?
Yeah, it is given by the YOLO documentation about the filter. If we go through the documentation, they said if we have one class, use this, and if we have three, the formula is given by YOLO, and 80 and 90% all is suggested by them.
Okay.
Yeah.
And what is the role of subdivisions here?
What happened when suppose we have taken a batch of 64? We are assuming we have a GPU which can process 64 images in a one go. Okay, then we are dividing this batch in we are subdividing this batch according to, okay, divide this batch in for a memory, divide by 16. So one batch will have 64, subdivision will have a 16 in it. So we are passing 16 images in a one go to the YOLO architecture. That's the purpose of batch. Because in training we will have 20,000, depending upon 10,000. In our case, we have 500 images of a license of a car. So we can't give 500 images or 10,000 images in a one go to a network. So we the batch divide that data in batches, and batches are further divided into subdivision, further divided by subdivisions. Okay, Vishal. Hello.
Another one is, another question is, are we not sending 64, which is batch size, to YOLO?
Are we not? Yeah, 64 we are sending to YOLO. Yes.
Okay.
If you, I didn't get that question actually.
So, question is, are we not sending 64, which is batch size, to YOLO?
Yes, but total images. Total images. Suppose we are going to train this YOLO for a license plate. I got an images around 500, but we cannot send 500 images in a one go. We are loading a 64 images in a one go and further subdividing it into by subdivision, whatever subdivision we have provided to it. I
Okay,
hope.
so a follow-up question on this is how. So follow-up question to what you just said. How is subdivisions exactly different from batch size? In this
uh,
example, are we sending 64 images at a time or 16?
64 at a time, and if we divide, suppose batch is 64, if we divide by subdivision, some whatever a value we have given, let's say we have given 16, so we are dividing 64 by 16, we are sending 4 images at a time. So I got your question. So we are sending 64 4 images in the end. We are sending 4 images to the YOLO. It's all right.
Yeah, go ahead if any more questions are coming. Yeah, they're saying okay.
Yeah. So more changes we need to. So this is one of the configuration. Instead of doing it in a darknet, what I did, I made a copy of it with that will contain all the configuration. Instead of directly doing in the darknet, I left it there. So we can do all the changes um, in different location, and we can refer that. Okay, we can point that one to the darknet. So in this case, because I have a small GPU, so batch is 64, subdivision is 64. In the end, we are sending only one image to the GPU. In my case, with my system configuration, but on a cloud, maybe it can be more. If we change it to 32, 64 divided by 32, we are sending 2 images at a time to the system. This is one of the configuration that we change. Another configuration that we have to change is um, OBJ names. This will contain the name of the classes that we are going to recognize. If we have one class, it will contain only one label in it. If we have more than um, one, like in Coco, we have 80 classes, so it will contain another one label per line. So it's a label for it. Another configuration that we need to make is number of classes. We have to configuration that we have to change is OBJ data, number of classes, one, training data set, path of a training data set, path of a validation data set, names, the label, and backup. What happened when we train YOLO? It make a backup of weights after every 100 iterations. So after every 100 iteration, it's dumping a weights. So we need to mention where it will dump the final weights in it, where it is going to store the final weights. And let's see what contain in the train.txt. It contains the path of an image. This is the complete path for the image. Where my images is having where a system contain image. Similarly, the test one, it got less data as compared to the train one, dividing into 18 and 20 ratio. So you need to download uh, weights to we are going to start with these weights: YOLO 4 con 137, which is recommended by the YOLO. If you are going to train that, start with these weight instead of starting from the scratch. So these are the configuration changes we need to make, and I got my images here, and this is the YOLO labeling. This is the, we will talk about it later on. This is the labeling of the images. And to train Darknet, we are going to use Darknet C file detector as an argument, then train, and giving a path of OBD data, which contain path for classes, class label, train dataset, validation dataset, and the configuration file and the weights. Let's start this, try to do this, and we are not going to complete it, but let's see. So I hope it's visible to you. The iteration has started. One iteration is already done. And here, right now, the loss is here. It will start and gradually drop like this with the number of iteration. The 2000 that we have mentioned here, okay, for one class, it is going to run for 2000, and for every after every 100, it's going to dump a weight in this backup file, backup folder. All right. And I already did all the training. So finally, I got this weight, YOLO 4 weight, and this is the simple Python program I wrote for detecting the license plate. So yeah, that's how you train. And after passing, mentioning the class number, the class configuration which contain batch network configuration. This is the weight and the class name, like plates and like plates, or whatever the classes you have in the Coco. If you want to do it for 2 or 3, the class names. And to prepare a data for how to prepare a data set for YOLO, let's see how we can do that. I used a tool, label img. You can install it by pip install label img. Then we can launch from the command line label img, and you don't have to mention the path folder. You can on you can start this tool by entering this label. Let's open it. So in here we have to select Pascal or VOC or YOLO. We are preparing it for YOLO. Let's see how we can do. Then we have to select, okay, create a rectangle box. Label it plates. Okay. Use default label. You can hear plates. Then you have to save this. What it is going to do, it is going to save a text file with the similar name as of the image. The image name is car1.jpg. It is going to create a text file car1.txt. Let's open this text file. This is the class. Because we have only one class, it's starting from 0. It's referring to that. This is the center point, center x point, center center y point, height and width of the annotation what we did. And this is the class file. Okay, plates. And this the combination of this is we are going to fed we provide it in to the YOLO for training it. Then next image. Similarly, you can make annotate more images. So yeah, it will create text file with the same name. Object class which is 0, center x, center y, width and height. This center x is absolute x divided by the image width. Height is again absolute height divided by the image height. So that's how you can train YOLO to detect a license plate or any other class. These are the steps you need to do, and you can find all the information step by step uh, on my GitHub. You can download the code and everything from here, and which I'm going to share it with Vishal, and Vishal can share it with you guys.
You can share right now. I will shoot it right away.
Yes. Can you send me a message and then I can
Sure.
share it with you?
Sure.
Yeah, chat. Yeah, okay. Yeah,
Okay.
yeah. This already we covered it. And suppose if you somehow your system breaks, stops, you can restart with your last wait by using this command. Last wait. Any questions, please? That's yeah. When you can stop training, this is after 2000 iteration. The loss started from here and gradually it decreases. That's why we are able to get an accuracy of 90 and above. Vishal, I'm done.
So,
Any
audience,
questions?
any questions here? You can ask questions here, or you can contact Manjeet directly through his GitHub profile. So he has been earlier with 197 Communications in India, and then he migrated to Australia. But then he could not leave his technology stack behind, so he joined our machine learning, deep learning course, and now he's researching in computer vision there, trying to solve some problems. So since I'm not seeing any questions, I'd like to close it here. This session was being recorded and will be made live in 2-3 days time on our SalesStrat YouTube channel. And most of the people who are attending today, I think, are already part of our AI lab or our regular attendees. So you'll be able to see it on YouTube. So look forward to future sessions by Manjeet. One question has come just now.
Yeah.
So can it be used for Indian license plate detection?
Yes, I just showed you one of the uh, this image. You can use it. Let's see. Uh, I have an example of it. I used it. You can use the same for Indian license, but it's better if you can train. If it's better if you can train on Indian license also.
So gentleman is asking who has the training set. In fact, Manjeet had been looking for Australian number plates for some time to be able to give this session. He was looking for same data there, but he was finally able to manage some data and was able to train it. Uh,
Yeah.
so people here on the session, I think, are from across the world. So there's one gentleman who says, "I am from Oman. Is it
Yeah.
possible to use?"
So what you can do, because when I was reading about license plate, um, in Oman or some other country, there are Arabic words written on it. I don't know about the Oman, but yeah, in other countries there are Arabic words written, and in India it's already English, and here numeric numbers are different. But in other states they have a different numbers. So what you can do, instead of starting from the YOLO, you can take these weights, give your own data, and train further on it. So it's transfer learning will be better for it. You can try on Oman numbers. I don't know how much the accuracy is going to be, 80%, 90%. But if you want to increase the accuracy, you can further train with your own data set.
So he's saying here both Arabic and English available in number plates.
Okay.
I think that should be doable.
Yeah, it's doable. Nothing wrong with it. But yeah, you have to give uh, data. You have to provide the data and you have to train it. You can use these weights, check what the accuracy is. If it's not satisfactory, you can further train it. And it's all available
So
on the yeah.
other two questions are if he can collect a good enough data set, he can train his own weights, right?
Yeah. And
And what would be a good data set size?
right now, I use 500 images
Okay.
only, 550, around 600 images. One thing which I
Okay.
learned when I was training YOLO for it, what happened? Do not provide um, different resolution images. If you can provide, suppose, uh, 5,000 data set for a training, it's a different story. You can have a different resolution in it. Right now, with the 500, the data set that I used, all are having a same resolution, 1024 by 1024. But if you further add 100 images with different resolution, the accuracy is going to drop. What happened? I asked my friends to send Western Australia license photographs, and they used their phones and send it through WhatsApp, through email to me. And when I trained it, YOLO, I found after a certain iteration, the accuracy was dropped drastically, and in some images it was not able to recognize license plate. So I realized what I tried to debug it, and then realized because the data set that I provided is having a different resolution, but the number of images was not enough to train it well. YOLO is capable of taking different resolution, but provided appropriate number of data set. Suppose 2000, what they suggest, provide at least 2000 image, more than 2000 images for one class as per their paper.
You are saying 2000 would be minimum required as per if we have to go with the paper we are mentioning?
What they suggest, if you go through the documentation, it's their suggestion, but the system is
Okay.
so good, the YOLO architect so good, with 500 we are able to achieve a good result. But in a production system, obviously this is a
So any
testing
other
system.
questions, audience? Right. I don't think front and back plates will differ in any region, right?
I don't know. Here it's same.
Yeah. So
But
okay.
what
Another.
the thing is, you have to provide both sides, because when you are training your system, it will go through more of the different phases or different, you can say, data augmentation, different set of data set. Tomorrow,
Mhm.
if you are just feeding the back of the car, maybe tomorrow it's not able to recognize the license plate from the front. That's
Okay.
how image uh, recognition work. Yeah. Yeah. Another question. Yes,
Oh.
sir.
What was the map that was achieved?
Uh,
MAP.
Yesterday I made few changes in it, so I don't have it right now. But with the command, you can we can get it later on. So
Okay.
right now I don't have it because for a map of it.
Okay. And is
Yeah.
this only software module or have hardware as well? This is again from Oman.
It's only a software module. We are just providing a static images in it. If you want a live feed, so then you have to make a proper system where you're taking a feed from webcam or commercial video cam, feeding it to your system and dumping or storing it in a database. This is only just on a static image or standalone image.
Okay. All right. Any other questions, audience? So none are coming. So we would like to close it here. Thank you, Manjeet, for the time and your session.
Yeah.
And I suggest you do the sessions every month, once a month. Your sessions are good.
All right. Thank you. Sure.
Right. And thank you, audience, for joining. And have a good day and stay safe.